So good afternoon, everybody. It's 4 p.m. So it's time to start our next episode of the new product releases of the EPIC members. The goal of this meeting is to give the opportunity to all EPIC members to present their new developments, their new products from a more commercial point of view. And today we will have some very interesting developments of 5 EPIC members: Bühler Group, Exail, nortus, Systronic, Ansys, and also Menhir Photonics. So just in case there is somebody in the room that doesn't know EPIC, we are the European Photonics Industry Consortium. Our goal is to help the members and also the company outside the consortium to find new partners, to find new collaborations, to find new customers as well, through our networking activities and also through our technology meetings. This is a short summary of the benefits that we offer to our members. So on one side, we can help with technology requests in case there is somebody that is interested in finding an alternative supplier for one component or a new supplier for some component that they are going to start using. We also give access to market reports. For example, yesterday we had a very interesting online meeting about Raman technologies developed by Thematis. So these kind of market reports are available for our members, and they are normally included with a discussion with the developers of the document. We also help in access to markets with human resources support and also to access to investors, or the other way around, to find companies that are interested in being invested or being acquired. So we connect companies in both sense. And as I mentioned, networking. So one of our main goals is to have the people from different parts of the supply chain together in the same room so they can talk and find common points of collaboration and discussion. And regarding these networking activities, one important part are the EPIC events, where we try to bring everybody, as I mentioned, in the same room. Some of them are physical, like the ones I'm showing here. I encourage you to go to our website and see all the ones that we will have until December already prepared. Next one will be in May about XR at Microsoft in Finland. Also in June about photonics integration and packaging in Berlin, in Germany, at Fraunhofer ICTM. Then in June, we will talk also about the specialty optical fibers at Photonics Bretagne in Lannion. And in September, we will move to Norwich in the Netherlands to talk about photonics for new space during the ESA Industry Days. And talking about photonics for military optics at Sony DADC. And we will be present at the conference, so we will have also a networking reception there. So if any of you are attending the conference, feel free to register and enjoy the networking activities there. And of course, we combine with online meetings, some of them about technology, for example, photonics for thin film fabrication, characterization, vision and air research as well, or photonics for sea exploration and oceanography. And we combine, as I mentioned, with workshops on human resources, also sustainability, to learn from companies that are already involved in this process. And then we help also marketing departments with our meetings. And we will have one in June about social media with a focus on B2B companies. And this is the agenda for today. So as I mentioned, we will have presentations from 5 companies. So Bühler Group, Exail, Systronic, Ansys, and Menhir Photonics. We will talk about lasers, high power lasers in the case of Exail, also about CPA pulse amplification in the case of Menhir Photonics. We will talk about optical design with Ansys through their CMAX Optics Studio. We will also talk about the metrology solutions of nortus Systronic, and we will start with the evaporation system that Bühler Group has developed. So I would like to introduce you Daniel Pereira, that is sales manager for the Semiconductor at Bühler Group, and he's going to present the new label optics LTE 700. So Daniel, the floor is yours. You can start sharing your screen.
Hi, everyone. Thank you very much. Can you hear me fine?
Yeah, we hear you well.
Yeah, okay, great. Thank you. Then I'm going to share my screen now and start the presentation. So if everything is working out fine, I should be able to see it now. Yeah, great. Thank you. So it's great to be here and to actually present to you our latest development in semiconductor, the labeled optics LTE 700 or long throw evaporator. First of all, a little bit about myself. My name is Daniel Pereira. I'm a sales manager for the semiconductor market segment at Bühler Labeled Optics. And this is our latest product that we are introducing in the evaporation family. And today we're happy to actually show a little bit the first results and the first developments that we've done in this field. Before getting into it, a little bit about Bühler and Labeled Optics in particular. We are experts in vacuum equipment for the fields of optical filters in all various types of substrates. We are a worldwide company, so we are present all around the world. I'm coming directly from Alzenau, not far from Frankfurt, so in Germany. And we also have application centers in the US, in Raleigh, and in China, in Beijing. And together with these 3 application centers, we have installed more than 3,000 systems for all various applications in optics and photonics. And we have a total of 650 employees worldwide that encompass everything that is necessary to design, build, and install these kind of systems. We have a turnover above 300 million Swiss francs. We could talk in Swiss francs because Bühler itself is a Swiss company. And about 5% of our turnover is developed into innovation. And the LTE system that we are presenting here is a result of that innovation. So what we do in our product portfolio is showcased in this slide. So we specialize in vacuum processing and coating of substrates for various applications in optics. We are divided into 2 groups, figuring and coating. And within the coating group, we have solutions that range from the EUV to ER applications. And this is divided into sputtering machines, evaporation, CVD machines, and so on and so forth. So depending on the application, depending on the type of substrate you might need to have coated, we look into our customers and we look into our products to develop specialized solutions to tackle specific applications. What brings me here today is the LTE, long throw evaporator, which is a spin-off of our existing technology called the Cyrus Pro. So we are developing this system with another system in mind, and we are expanding it with the introduction of this new machine. And where do we come from? In the slide you see here, we look into microelectronics fabrication, where it is very common that structured wafers need to be coated with a certain film or a certain filter, and from the coating part, then comes then there's a step where we remove what we call the photoresist in order to form a specific pattern on a substrate. So whenever we want to create specific patterns on a structured wafer, we usually follow what is shown here in this diagram here. So what is important is when we're doing the coating, and we have such a structure here with the photoresist, as you see here in the second picture, is that we need to avoid that we do sidewall coatings. Meaning, if we want to really reproduce a pattern onto a substrate, we need to avoid that the coatings are going to where basically we don't want them to go. This is what we call a directional coating, and we need to have a certain direction of the evaporation profile into a substrate in order to avoid that we don't create shadow effects and we don't create patterns that we don't want to reproduce. And this is where the LTE comes from, in this world of the evaporation with a specific direction and to avoid sidewall coatings. And this is where we are developing our system. And this is what we show here today. And this is the first system of its kind, the LTE 700 long throw evaporator. And we designed this completely thinking of microelectronic fabrication and really thinking about this directional coating capabilities. First of all, we have a source to substrate distance of about 1.3 meters, as you can see here. We have an electron beam gun positioned at the center of the chamber, also to allow this perpendicular aspect of the evaporation profile. We can coat wafers up to 6 inch. and we can coat multiple wafers. So depending on the request from the customer, and we can even mix between 6-inch, 4-inch, or on 1-inch, depending on the needs. Meaning we can do this. We can think about a small mass production environment or even an R&D environment. And we also think about integrating our system with ion-assisted deposition for surface treatment or removal of properties from the substrate. We think about cryopump and cooling trap to optimize the vacuum performance, and we do all of this with a very compact layout to be able to integrate into clean room with minimal space requirements, so without affecting much the space on the clean room. And the result of this is that we can actually demonstrate. And here I would like to shout out to our colleagues at EPFL for conducting these measurements, where we have produced 100 nanometers aluminum film on such a structure, really how it's shown here. And we made these SEM pictures to really see and to prove that we have this directionality coating. And you can see here, when we look at this points here on the sides, which is the photoresist, you actually can see that we are producing the films without sidewall coatings, meaning we can actually reproduce specific structures from the concept really to production and to reality. And if this has tweaked your interest, you're more than happy to talk to you. So you can contact me, or if you want to, we have the official product launch where we're going to show this and a lot more for our Leibold Optics LTE long throw evaporator 700. 1 week from today, we have 2 possible sessions. So if you're interested, feel free to register. And this is the last slide. So thank you very much.
Thank you very much, Daniel, for introducing this product. We have time for questions to Daniel. So I encourage you, as I mentioned in my comment, to raise your hands and make your question directly to Daniel. Also use the chat box to make the question. I will perhaps start, Daniel, with a question about the final kind of application. Which kind of examples of applications do you think they will need to have these specific, I would say, strange structures where you need to really control well the level of lithography and the position?
Yeah, that is actually a very good question. One application is within, for example, RF communication in what is called a SAW filter or surface acoustic wave filter. In the case of these filters, you need to do, for example, what we call 3D fingers, where the fingers are basically evaporated with a specific profile. And you have to have such a tight control over the films that you are producing, so you don't get contacts very touching each other. And this is where evaporators with a long throw and the directionality coating come to play. So applications such as this one can be of interest. And within the world of R&D, for example, it can be quite useful. A system like this to be installed in a laboratory or environment like this, so to do different investigations on types of processes that are needed for this.
And you mentioned about the size of the machine. What about the supplies that must be given to the machine? Is just electrical power supply, and then depending on the evaporation, the material that the user is interested, right?
Exactly. So meaning aluminum, titanium, gold, all these type of materials that are standard used in evaporation, they can also be used in this system.
You mentioned wafers. Does it mean also that must be circle shapes in the sample? Can be also square shaped substrates?
Not necessarily. Yeah, it doesn't need to be round wafers. Any type of shape can also be used. Of course, then we will have to design the necessary holder. But yeah, anything can be used for sure.
Okay, perfect. So
one question.
Yeah, please, Hervé.
Yes, please.
Daniel, do you know if your machine was already tested and used for lithium niobate substrate?
For lithium, you mean doing coating on lithium niobate substrate?
Yes.
Yes. This has been tested. Yes.
Okay.
You mean for example, for RF filters?
exactly, or it can be for modulators, as we are doing.
Yeah, for sure. Yes, this is possible.
Yeah, perhaps if you're interested, Hervé, in discussing later more in detail, I can introduce you to Daniel by email, and you can make more deep questions about the interest. Okay, great. So Daniel, thank you very much for the
thank you very much,
presentation. Thank you for presenting your new product, and good luck in the next weeks with all the launches and
thank you.
and the activities you have in mind.
Thank you very much.
And we can proceed with our next speaker, that in fact is Hervé Gouraud, Sales Director of Exail, and he's going to present their phase modulator for high power lasers based on lithium niobate. So Hervé, the floor is yours.
Thank you very much, Antonio. First, do you see my screen? Is that okay? Yes? Okay.
Everything good.
So thank you, Antonio. Thank you, EPIC, to have organized such a session. It's always a pleasure to work with you. Thank you for your communication and your help. So my name is Hervé Gouraud. I'm Sales Director for the Photonics division of Exail. And today I will introduce our latest phase modulator. It's a very low VPI phase modulator dedicated for high power fiber lasers. Sorry. So very shortly, if I have to introduce Exail, so Exail is a merge of two techno champions, AX Blue and ICA, and today we are a very large company of 2,000 employees. Today we are registering more than 320 million euro. We are definitively an innovative company, as we have 20% of our revenue invested in our research and development. We are a French company. We have today 21 production sites based in France, but most of our sales is made outside our country. So we are doing 80% of exportation. About our product, we have a very, very wide range of product. We are designing, manufacturing, producing components, equipment, platforms, and very complex systems. We are vertically integrated. That means all our components are embedded into our equipment and platforms. We are engaged in the maritime, navigation, defense, and photonics market. And today I will introduce only one component from our photonics portfolio, which is the lithium niobate modulator. So when we are talking about phase modulator, there are a lot of application and photonic setup. So I will not cover all of them, and I will focus only about one phase modulator dedicated for high power fiber lasers. In our company, we are dedicated a specific design for a lot of different application and phase modulator use. So for instance, we are doing low frequencies phase modulator for PDH, frequency laser technique, but also low frequency phase modulators dedicated for coherent beam combining laser structure. Phase modulator with low VPI and high optical input power handling capabilities. This is what I will introduce today. This kind of components are used for either spectral beam combining laser technique, but also to avoid the Brillouin effect by spreading some tones to avoid this Brillouin effect. We are also designing and producing DC-coupled phase modulators. This type of components are used for quantum and especially quantum key distribution application. We have also developed very unique free space phase modulators. That means there's no fibers at both ends of the modulator. We are gluing some silences, and this kind of modulators can be used for LiDARs application. We do also a lot of very high-end phase modulator for space application. It can be for PDH, it can be for quantum application, different type of application, but for space grade. And then I will conclude with a small conclusion. So today I will introduce only the phase modulator coming with a very wide range of bandwidths. with low VPI and with this very high optical input power and link capability. So a few words about the principle of these phase modulators, but also the application. So with phase modulator, we will modulate with gamma the electrical field, and the Y is, as you can see, is dependent of one value we can call the VPI of the modulator. There are many different applications where the phase modulators can be used, the spectroscopy and the laser cooling experiment. As said, for the fiber amplifier, we need to broaden the spectrum to avoid this Bray-Wien effect. Today, for high energy lasers, for directed energy lasers, several techniques are using phase modulators, either for coherent beams combining, but also spectral beams combining. As said also, low frequencies phase modulator for PDH laser locking technique, for telecommunication, for DPSK, and a lot of phase modulators are used today for lidars and gyroscope. So when we are talking about phase modulator, most of the specification rely on the optical input power, the VPI, and insertion loss. However, we have to focus on second range of specifications, which are very important when we are looking for high-end quality or high-end performance product. The residual amplitude modulation, the polarization dependent loss, the polarization extinction ratio, if the modulator can be DC coupled or not, if the modulator is resonant in order to minimize the VPI, if the modulator can handle a lot of RF power or a lot of optical power, if the modulator is fibered or free space. And you have a picture of this unique phase modulator. You can see there's no fiber. It's a free space phase modulators. We can supply also this kind of phase modulator based on base plate. It's for OEM customers which are looking for very compact and low price solution, and also resistant radiation components. You have a picture of a space grade component we are today supplying. So we do all these several types of components depending on the application, but depending also on the environmental application. So today I will focus on this new product, very large bandwidth modulator coming with very low VPI. So you can see this acronym LVP for low VPI modulator. I give you here the main specification of this new modulator. It has a high cutoff frequency in the range of 12 volt. However, this modulator can be used up to 20 gigahertz, sorry, 12, high cutoff frequency, 12 gigahertz, not volt. And this modulator can be used up to 20 gigahertz because it has a very flat S2N transmission. As you can see, it has a very low VPI. It was measured at 2 volt at low frequencies and 2.3 volt at 1 gigahertz. And because it has a very large bandwidth, this modulator has only 3 volt of VPI at 10 gigahertz. Very low insertion loss in the range of 3 dB. And also you can see that such modulator can handle a lot of RF power up to 33 dBm and up to 25 dBm for the optical input power. About the VPI versus frequency, it is well known that the VPI of phase modulator, but also amplitude modulator, are frequency dependent. So we have measured the VPI of phase modulator using we are measuring the frequency response of this modulator, and we are checking, we are measuring the level of the Bessel function of the output of the phase modulator using electrical spectrum analyzer. And you can see that such phase modulator has a very low VPI in the range of 2 volt at low frequencies, and the VPI of the modulator is still low. We have measured 3.5 volt at 13 gigahertz. So it's very low compared to, as you will see, our competitors. When we when we check the modulator's specification, we check the papers, but we have to also evaluate the behavior of the modulator, because such modulator can be used for industrial application. So for such modulator, we have performed an edging test. Such modulator was so submitted to a temperature of 85 degrees with an input power of 300 milliwatt. And as you can see, there's no degradation of the insertion loss over time. And we have registered more than 16,000 hours of such a test without any degradation. We only see the insertion loss variation below 0.3 dB only. We have also measured the behavior of the modulator when the output temperature is moving, is changing. This is really a real case where the modulator are placed, outdoor. So we have changed the temperature from -30 to 35 degrees. Input power in the range of 300 milliwatt. And as you can see, whatever the temperature, the insertion loss and so the output power are very stable over time. So that means our modulator can handle optical power up to 300 milliwatt. We have measured the edging and we have measured more than 16,000 hours without any degradation. And we can conclude also with this test that our modulator is not dependent with outdoor or outside temperature. Finally, I have played to check what are the status of our performance from the modulator competition. And I have checked, the bandwidth, the VPI at low frequency, high frequency, the optical input power, the insertion loss value, and the RF input power. In green, that are the best performance today proposed by the phase modulator manufacturers. And you can see that Exail phase modulator is always the best. So I can conclude that Exail today offers the best near-infrared phase modulator today available on the market, and one application is for spectrum broadening. So finally, I will conclude with an exhibition we are organizing. It will be the 28th of May. So the topic is the high energy lasers, either for scientific application for laser to matter interaction, but also the high energy lasers for direct energy laser, either for civil or military applications. So this event will be is organized by Exail, and it will be based on our headquarters nearby Paris. So you have a picture of where the event will be placed in our headquarters, where we have this beautiful castle, and we have this beautiful also auditorium where we can welcome more than 300 people. So the inscription, the registration is free. You have I shared here the planning of the day. Many key people attending this event as speakers: Onera, the STFC, CVAN, the Fraunhofer IOSB, IFRL, the Thales Group, EXPLA, also the Lawrence Livermore, the French Nuclear Agency, the Lully 2000, etc. So do not hesitate to come. The idea is really to gather information to speak about high energy lasers. It's free. You just need to click on this link and to register yourself. Thank you.
Thank you very much, Hervé. We have time again for questions. I can start with a question about, you mentioned that the spectrum broadening will be application for your product. What will be the maximum broadening that you can get with your modulator?
Yes, it's a very good question, but I cannot answer to this question because it depends on some factor. First, the RF input power, and also the RF frequency applied to the modulator. So the width of the spectrum broadening will depend on these two factors, and user manage to apply the right values.
Okay, good. I don't know if there is any other question. Well, if not, Hervé, thank you very much for the nice presentation.
Thank you very much.
And also thank you for introducing your event that will happen late in May. So we encourage all the attendees to check the website and see the agenda and the nice speakers they will have in Paris.
Thank you.
And so we can go with our third speaker today. So I would like to introduce you, Mr. Jürgen Kreis is founder and co-owner of the company Nortus Systronic, and he's going to present the new D7 interferometer. So Jürgen, I don't know if you are there already.
I am there, yeah.
Good, so the floor is yours. You can share your presentation.
Thank you very much. Yeah, first of all, a very warm welcome also on behalf of Nortus Group. My name is Jürgen Kreis. As was just introduced, I'm one of the co-founders of Nortus. Our managing director, Mr. Bernd Dietz, is participating only remote today, so via YouTube, but he will be more than happy to answer questions afterwards. And we are very proud to be a member of EPIC for both Nortus Systronic as well as the sister company, Nortus Optronic. I don't want to talk too much about these companies. Actually, our aim for both companies is to really identify technological troubles, eventually to improve those, working closely with partners. And that said, over the years, the Nortus Group has compiled quite a number of very interesting technologies, and the D7 interferometer definitely is one of those. Just to give you a little bit of taste for what other products we are dealing with, mostly with partners of ours. This ranges, for instance, for Systronic, from handheld spectrometers via calibration sources, test systems, optical components, and quite a number of others. If you're interested in more details, please visit the website. There will be the contacts at the end of the slide show. But let's go into the D7 interferometer. So we claim that to be a technology breakthrough because of some unique advantages. And I should say the technology also has been patented both in Europe and the US as well as in China. So the underlying principle is so-called PSPDI, which stands for Phase Shifting Common Path Point Diffraction Interferometer. This sounds quite complicated, and for that I would definitely spend a few minutes in explaining this approach. And the working principle, essentially, the basic principle of the system is to have two wavefronts generated by the system itself by using pinhole diffraction, which generates then coherent beam paths. The test wavefront and the reference wavefront, they are both generated by the system itself, which also means that we don't need any reference surfaces as it is known, for instance, for Fizeau interferometers. So if for a simple understanding, we want to measure the interferogram of a concave surface, and I'll show what the implications for convex and flat surfaces are after getting the basic principle. Then we would start by having a laser source. This can have different wavelengths, of course, and coupling that into a projection optics going through a pinhole. Then we would create a spherical wavefront first of all. If we then take a little bit more complex setup and split this wavefront into two beams and use a phase shifting piezo transducer to essentially shift the phases of both wavefronts and then couple them in again through the same pinhole, what we get is essentially a test wavefront and a reference wavefront. And taking the reflected image back to a sensor, this is the underlying principle of this approach. So the nice thing is this gives a very robust system with a very high sensitivity, which also works, for instance, of surfaces with very low reflection index. So for that, it can be used for a very wide range of applications. And again, the biggest advantage is we don't need any additional reference sources, which also have an implication on the achievable precision of this approach. So we believe there is, for typical applications, we can get a precision which exceeds typical Fizeau interferometers, at least by a factor of 10. More importantly is actually that this approach is extremely robust, and with that, of course, is extremely suitable also for quality control, for instance, in production environments. The cost benefit of not having the need for expensive test surfaces, of course, comes on top. So this is how the working principle is. How does a real system look like? It's quite compact, and here we see the basic system, which without any additional accessories can be directly used for concave test objects, with a minimum curvature radius of about 45 millimeters. Of course, if we have more towards the flat, the radius can go to unlimited. And if we now want to combine that, for instance, with or use it for flat surfaces or convex surfaces, then we need an additional optical collimator. This is the DA1, which is an optional system which can be used for both for flats and also for convex surfaces. In this case, for a flat surface, we would simply use part of the DA1 subsystem and then can directly measure flats up to 220 millimeter diameter. The system has an additional stitching mode, which also allows to go for larger areas than these 220 millimeters diameter. But then, of course, we need a sequence of measurements, and the software combines those to a comprehensive result. For the convex surfaces, then we do have then the second part of the DA1 being part of that, which then again collimates the beam towards that surface. So with that, we can go for max diameters of up to 210 millimeters and maximum radius of about 700 millimeters. Technically, it would be possible to produce larger collimators. There's a cost issue involved with that, of course. But again, also here, a stitching mode is possible. And in combination with these software features, it's also possible to combine convex and concave surfaces in the same measurement and stitch those together. For instance, if we have surfaces with a more complex surface structure. As I said before, the system can be used with different wavelengths lasers. So here's the example of the same surface shown with measured with the green laser, and then again with the red laser. For the second result, keep in mind that here the device under test was twisted by 45 degrees. But we can already see that, of course, also depending on the surface, the selection of wavelengths might have an impact on the overall result. For that, this flexibility also is quite important. For the sake of time, we can't show that many examples, just to show a few of those which we believe are quite important. So one of the strong capabilities, because of the optical setup of this D7, is that it can deal with surfaces with very low reflection. And this is an example here, which naturally results in a very low contrast for the interferograms. And respectively, we can see that even for such surfaces, it's possible to be for them to be measured with this innovative approach. Here is another example. This is the measurement of an aspherical mirror in here, and they were then from the customer compared to measurements carried out by the customer himself. Can't tell who that is, but the conclusion is that again we exceeded the possibilities given by another system easily with this approach in here. And to make this system also to be used with customer samples, we just recently decided to establish our own testing lab back at our headquarters in Wörth in Germany. So it's just some pictures taken there. We have tried to go for a rather flexible setup, having essentially possibilities to go for convex and concave and flat surfaces as well. So essentially all essential elements are there. For customer systems where a higher throughput is necessary, of course, these stages would be available also in a motorized way. Here, for demonstrating the working principle of the system, we choose for the more cost-efficient manual version, but that already allows us to demonstrate the capabilities of the system essentially for all types of surfaces. That said, we have also compared the approach with, let's say, more common technologies. And again, as we have seen in the previous talk, also here, we believe we have found a technology which really exceeds most of the competitive approaches by far and offers quite a number of advantages. As the slides will be made available afterwards, I think a few of the examples I already mentioned. For that, I skip off reading the slides to you. But again, I think speed, achievable precision, the very high flexibility with use of any kind of surfaces, and also very low contrast surfaces are definitely some of the strong points of the systems. This is the summary again. So we believe we have here a really innovative system which can really be a game changer for interferometric measurements. And again, we are really grateful that we could present that to the audience in here. And for those of you who want to know more, here's the contact details of Nortus Systronic. We are located in Wörth am Rhein in Germany. This is close to Karlsruhe. The email address of our managing director, Mr. Dietz, is shown here. So it's quite simple, bernd.dietz@nortus-systronic.com. And if you found the presentation interesting, of course, highly appreciated also for follow-up discussion. And again, thank you very much to the audience for your kind interest.
Thank you very much, Jürgen. We have time for questions. I can perhaps start with one question. Did you test this kind of solution with the freeform optics that is
yes,
interesting
yes.
topic nowadays?
Yes, we did, or actually our partner did. This would definitely require then for precision measurements a motorized stage. So we have seen the rather simple setup that we have in Wörth am Rhein. In combination with the motorized stage and the combination or the possibility for the software to stitch images, it's also possible to be used with freeform images. We have one customer who is in the application of augmented reality, where you need rather complex optical surfaces. Again, you're not allowed to say who that is, but this is a typical application where exactly that feature is necessary.
Good. And regarding the illumination wavelengths, do you also recommend to the user, depending on the application, do you now will use your setup for testing applications to perhaps find the best illumination wavelength to each component that you receive a request? Or how does it work?
Actually, the system is able to be combined with different wavelengths sources. So, for instance, we have one customer who, that was that one example I was showing, who is able to switch between a red and a green laser. And depending on the complexity of the optics and the impact, for instance, of different coatings, it might even make sense to go for instance, 3 different wavelengths. This is easily possible. This can be either provided with manual switching, where you just exchange the fibers, or an automatic exchange of the coupled fiber. So both is possible. For the lower cost version, it's quite easy to exchange the fibers manually. If you want to put it into high throughput production, the motorized exchange of the optical coupling, of course, is more recommended, but both is possible.
Good, perfect, very interesting. I don't know if there is any other question for Jürgen. If not, thank you again for the nice presentation, and everybody has your email address for further discussion. If somebody's interested, can contact you directly. Thank you for
Thank you very much, Antonio.
So let's go with our next speaker. So we will have Tom Pickering, Manager, Product Management at Ansys, and we are going to learn about their what is new in their Ansys CMAX Optics Studio. So Tom, the floor is yours.
Appreciate it. Thank you, Antonio. Can you just confirm that you can see my screen?
Yeah, everything good.
All right, perfect. Thank you so much. Thanks, everybody. Thanks for the opportunity to speak with you all. So thank you, Epic, for being able to introduce our latest updates. As Antonio already mentioned, my name is Tom Pickering. I'm the manager of the product management team for Ansys CMAX. And today I'd like to discuss with you our latest release, which is called Ansys CMAX Optics Studio 2024-01, which is now available for download on ansys.com. So let me see if that works now with the advancement. There we go. So In case you don't know, Ansys Emacs is now is part of a multi-product optics portfolio within Ansys Optics. So Ansys Optics is a multi-physics simulation platform for problem scales from various scales. So you can start from the nanoscale being numerical, via the macro scale being Optics Studio, to the system scale being Ansys Spheres. So the numerical suite includes FTTD. It's a 3D electromagnetic solver, which is the industry standard for modeling nanophotonic devices, processes, and materials. It also includes mode, which is used to design waveguides, fibers, and couplers. It includes several multi-physics solvers, and it also includes interconnect, which is for simulating and designing photonic integrated circuits. Then we have Optics Studio, which is the standard tool for optical imaging design. So you have everything that you need to simulate, to optimize, to tolerance your optical design. You can design high confidence virtual prototypes that you can then thoroughly analyze before going into manufacturing. And finally, we have Ansys Spheres. And Ansys Spheres is dedicated for the design and measurement and the assessment of light propagation on a system level. So in a 3D environment, you can design any sort of like lighting design and develop optical sensors such as LiDARs and cameras within a realistic environment. And you can also like factor in environmental effects onto your overall system performance. So this is just a quick introduction for our portfolio. And with this, I would like to dive into the actual release of 2024 R1. So 2024 R1 for Ansys Emacs has a sort of like 3-pillar focus. And our first focus was on the meta lens simulation, so advancing a meta lens simulation by integrating diffractive optics and meta lenses into a more macroscopic optical modeling. So this is a connection between Ansys Numerical and Ansys Optics Studio. The second pillar is enhancing the striatal analysis capabilities. With this new workflow that we put into place for importing lens geometries and optical properties from Optics Studio into Ansys Spheres, which is compatible with their physical camera sensor. And then finally is expanding the Optics Studio multi-physics workflow capabilities. And we can now load refractive index data sets directly into Optics Studio from a wide range of sources that include computational fluid dynamics tools such as Ansys Fluent. So these are sort of like the 3 main focuses. Foci, I always struggle with the plural of that word. But anyways, so diving into the first feature that I would like to highlight for you is for it's a feature that really leans itself for diffractive modeling and meta lens modeling. So we added a couple of more analyses, which is the phase slope map and the phase slope cross section, and we also added a couple of more optimization operands that help you with the optimization of those phase profiles. So with the phase slope map, you can now evaluate the tangential, sagittal, XY slopes of any type of surface, and making sure that the underlying face surface is actually manufacturable. So these analyses really help you with the integration of meta elements and other diffractive components in your system. And then you can analyze them with these with this map, obviously. I also already mentioned we have 2 new merit function operands that you can use during the optimization, and they really help you to constrain those phase slopes to keep the phase slope manufacturable once you're done with your design. So that's the 2 separate ones. I'm not going to go into the detail for each, but as I said, these really help you constrain your profile. So like this addition is really helpful for integrating diffractive components such as meta lenses or other diffractive components into Optics Studio. And so we've enabled this new workflow between Optics Studio and Numerical that really help you to take in a diffractive or meta lens component from Numerical directly into Optics Studio and being able to ray trace through this. So it's a bit hard to see because it's a little bit small, but maybe it's legible enough. So this is sort of like the 4-step approach that we now develop to help you with this workflow. So the first step is to define the target face profile for the meta lens. And the target face profile can be defined in several ways. So either you have it analytically, for example, you have a spherical or a cylindrical profile, or you can use Optics Studio to optimize a wavefront exactly to what you need, with a sort of to follow a polynomial coefficient, for example. And this is where the analysis that I introduced in the previous slide would help you with, right? So like exactly, it has the profile that you need, and then once you're happy with that profile, you can then take it further down your workflow. So you would then go into your step 2, and this would be done in Ansys numerical, where you take do a sweep of the parameters of a unit cell of your meta lens. For example, like one of the parameters would be the radius of a nanorod or the distance between 2 nanorods, that type of thing. And what this does is it generates a database of these parametric nano element responses. So once you've done that, you can combine these two things. So you can combine these two things. So you have your target profile, you have your library of nano elements, and then you generate the nano elements map to basically deliver that target profile that you then want. And then once you have that nano element map, you can integrate it into Optics Studio. You can see this here on this example here. This is a very plain example because it's just a spherical wave, but basically here would be the meta lens that has the target profile of a spherical element, and it propagates as a spherical element, as you can see here. And then once you're happy with the end, you can then, once you're happy with your design, you can then export the face map for manufacturing in a universally understood GDS format. So moving on, we also added a couple of like really nice features for imaging design. So we can now show the shape and the location of your entrance and exit pupil directly on your layout plot. This can rotate, so you can directly see here in this example of the double guys, where you have all your nice entrance pupil and exit pupils, and you can see how they bend and shape and where they are located in your design. This can be done either for paraxial or for real lenses, for both exit and entrance pupil. As I mentioned already, we also have enabled this new workflow that streamlines sort of like the straight line analysis of optical systems. So you can design your optical system in Optics Studio exactly as you used to. You fully optimized it and toleranced it, and then you can then use this export optical design to Speos functionality that lets you export the geometries from Optics Studio directly into Speos with a full recreation of the geometries. The bulk material data is supported, as well as the coding performance. So what this means is you can bring it over into Speos, put your optomechanical parts around it, and then you know exactly your stray light behavior when you put it in the full system environment, with your external sources and so on. A couple of more additions. So I mentioned already multiphysics was another big focus for this release. So we now have, on top of all of the optical parameters in our materials catalog, vendors can now provide us also with mechanical material properties. This is particularly helpful for these types of like thermal and structural modeling, simply because this type of data is really hard to find. It's always like a lot of literature research and like, Googling around the web, but it's nice to have it in one location. It sits together with your material, and it really eliminates the need to search for these types of properties online. So what can we do with this? As I mentioned already, we have a lot of like multiphysics effects already within Optics Studio. But with Optics Studio 24 R1, you will see a lot of changes within the star tab. So this is where the thermal and structural analysis lives. So it's called star for structural thermal analysis and results. Previously, there was a lot of focus on FEA tools, but ever since we now added the capabilities of adding computational fluid dynamics effects directly on your index of refraction. This is now moved from because now it also includes permutation fluid dynamics. It's moving from FEA into a full multiphysics. And you can see here the evolution of the model. Yeah, what like, you know, how it has progressed over the last few years. With this, I'm out of my final slide. So again, I really appreciate the time here and that I was able to talk to you guys. The features that I introduced for the last release were only an excerpt of what we have. So we have several. So the bolded ones are the ones that I talked to you about. The other ones you can read more once we share the slides through this platform here. So you can learn more either by clicking on the release notes or by watching a full webinar of this release, so you get a bit more information on. And as I mentioned, the newest release is already available for download on ansys.com. So thanks for the attention, and I'm happy to answer any questions.
Thank you very much, Tom, for all this summary of these new features. We have time for questions. And I would like to start perhaps with one, because I understand that when we add some new features, people need to probably some support from your side to start with the tools. So perhaps you can tell us a little bit how is the process of supporting, if you have any direct chat or any tool to make direct contact.
Yeah, that's so for each release, we typically with the features and with the release, we release like a set of either knowledge-based articles which could be found on the Zemax community page. There is also quite a lively community that discusses these new features on our website. But in general, if you can either exchange with our other users, or you can just send an email into support and discuss these new features of like how they can help you. You know, it's support@ansys.com, and they will help you. Very qualified people. I'm happy to answer any questions. And as I mentioned, the webinar should help a little bit too. We recently had a webinar specifically about the stray light workflow between Optical Studio and Studios. So if people want to know more about that, also happily forwarding that. You know, if you send me an email.
Yeah, in this case, it's very nice how the community is helping. It's something I really enjoy.
I would agree. Like I love being on our community page and just follow the chats that they happen.
Very good. I don't know if there is any other question for Tom. If not, thank you for the time today.
Right.
Thank you for the nice
Appreciate it. Thanks so much.
And let's go with the final speaker for today. So I would like to introduce Jonas Heidrich, Product Line Manager at Menhir Photonics, and he's going to present their CPA-free pulse amplification. So the floor is yours.
Thank you. Thank you for the kind introduction, and also for the opportunity to present our work here at this event. As you said, my name is Jonas Heidrich. I'm the product line manager for the 1030 lasers that we do at Menhir Photonics. We are, we'll tell you in a second a bit about our company, but today the topic is direct chirped pulse amplification, free pulse amplification, meaning that we can amplify pulses from our laser together with our partner Neolas, located in Germany, in Hanover. That doesn't require stretching or compression of pulses before and after the amplification. A quick overview about Menhir Photonics. We are a Swiss ultra-fast laser manufacturer located in Zurich. We do everything in-house, from the design of the system to the production here at our site. We own our own ISO certified clean room, and we are a fast-growing company approaching 30 people this year. We have many customers across the world that already use our systems at 1550, and also more and more the system at 1030 nanometer. We produce robust and reliable femtosecond lasers that are turnkey, easy to use, and compact systems with a footprint of a shoebox approximately, and this gives high customer satisfaction, which is also one of our key values. Today, I would like to show you what we did together with Neolas. This was a joint demonstration where Neolas used our Menhir 1030 femtosecond pulse laser together with the Neo YB amplifier modules to do an amplification demonstration. The laser, the two products have key features, which is I already mentioned for the lasers, is that we have a robust and reliable system, which has an excellent passive stability in terms of amplitude noise and phase noise, and also a high beam pointing stability, which is crucial for a modular approach with different amplifiers. On the other hand, the Neo YB amplifier module can be used in free space or fiber coupled. It has a super high single pass gain, so you get a high amplification with only one module, and is chopped pulse amplification free. When we combine these two systems, so the Menhir 1030 and the Neo YB, you, as I said, get the advantages of not having to do any pre-stretching and post-compression. You have compact all-in-one modules. Our laser, for example, only needs 5 volt and 1 amp, and that's it. So no other supplies. And also the Neo YB modules have everything built into the module. You just need a water supply because it's a high power module, and electricity. The pump, everything else is already included in the system, which gives you in the end a very cost-effective approach that is modular in a sense that you can, whatever pulse energy or power you need in the end, you can pick 1 or 2 stages of amplifications. In the demonstration that we did, we achieved more than 50 watt average power and microjoule level pulses, and this maintaining the low noise of our cedar, which is beneficial for many applications. Now in the following, I would like to give you a bit an overview of in how we did how the amplification is done and how easy it works. And this can be done in 3 steps. First, you take the Menhir 1030 cedar, which is here shown here, what different rep rates we offer for this laser. And if you look at it, we can directly provide pulses from the laser from about 100 megahertz up to 2.5 gigahertz approximately. Here I marked the standard repetition rates that we have. And if we want to go to lower repetition rates in the tens of megahertz, we use a pulse picker module to access this range, which in the end allows for a compact cedar system together with another small module to access this. The standard wavelength is 1030 nanometer, and from the system itself, you get approximately 200 femtosecond pulses with pretty high pulse-to-pulse energy stability and a low timing jitter between the pulses. In the second step, you take the Neolas Neo YB amplifier to amplify the cedar beam. In our test, we used a 216 megahertz system, but in principle, every system that we provide can be used for that experiment, for that demonstration. This beam is then, so the cedar sense gives you about nanojoule pulse energy. These pulses are then sent into what we call in this case the preamplifier module first stage, and only from this first stage we could already achieve 11 watts at 1030 nanometer, which corresponds to 50 nanojoule of pulse energy. When we look a bit at the output of this amplifier, as I said, we could reach, depending on the seed power, an output power of more than 10 watts, so 11 watts were achieved, and supported pulse duration of 500 femtoseconds. This is also is visible here when you look at the spectrum. Here in blue, we have the spectrum of the cedar, and due to the spectral narrowing, small spectral narrowing in the amplifier, we see that we can get still broad spectrum at 1030, which supports a lot less than 500 femtosecond pulses if they are, but they are slightly chirped. So what we measure after the amplifier is that we get 540 femtoseconds after this first stage. We have also characterized the beam quality, and we see that we have a pretty nice beam quality after the amplifier module at full power with an M square below 1.1 in both axes. And Neolas at the time directly demonstrated also with their conversion module to the green high conversion efficiency with 6.5 watt power, which was also plug and play. So this is also an option that can be done at any power stage. Here you see that the approach is pretty simple. So you just take the laser and the amplifier on the table, and with this you can reach already 11 watt. In step 3, we showed then that it's straightforward to go to the 50 watt range. So by taking 2 Neo YB amplifiers, a preamplifier and a main amplifier stage, and this allowed to go to on a linear scale with the pump current up to 55 watt at 1030 nanometer, which corresponds to 250 nanojoule. Here it's important to mention that we can also achieve microjoule pulse level with these 2 amplifiers, because in the amplifier sees above 1 megahertz repetition rate quasi CW light. So if you would imagine that you send in a 50 megahertz beam width, which corresponds to only a fourth of the amount of pulses, you would then achieve microjoule level pulses. Because we provide low noise cedars and Neolas also provides low noise amplifiers, we did a noise analysis on this demonstration, and here we see that this was done on the 11 watt stage. We see that the amplifier was operated with a seed of 140 milliwatt, and at full amplification to 11 watts, we compare the amplifier noise and the oscillator noise, so after and before the amplifier, and we see no significant changes in the relative intensity noise of that system. It means that the system maintains the low noise properties of the cedar. And when we integrate this noise, we see that we are well below 0.1% RMS noise. To conclude, what I showed you today is that you can easily use the Menhir 1030, and depending on the needs of the demonstration or the application that you want to do, different amount of Neo YB amplifiers to reach easily 50 in a plug and play configuration, 50 watt average output power up to microjoule level of pulses, and this at a low noise level. This chirp pulse amplification free, compact and cost effective approach can be used for generating generating electron pulses in photocathode lasers, in enhancement cavity experiments, for example, or if you go to higher repetition rates, gigahertz burst or pulse stacking of pulses, and many more applications. So please get back to us or to Neolas. You can contact me directly under jonas.heidrich@menhirphotonics.com, and also both companies under contact@menhir and info@neolas.com. Thank you for the attention, and again, thanks for having the opportunity to show you what we've done here today.
Thank you very much, Jonas, for the nice presentation. We have time for questions. I will perhaps start with one doubt about the option that is free space. How critical is the alignment between the components? Is something that it can be done easily by an experienced user?
Yes, so we have been, and also Neolas has been looking into that. There's two options. Basically, you can, if you want to work with fibers, you can also do fiber alignment, like plug and play of the modules with a fiber. But if you do it free space for higher powers, it is not that critical. So as the laser itself, the seeder itself the beam is very stable, and once you place the module on an optical table, you can just align it, and then it stays where it is and works quite stable. One thing to mention here is in case one needs a full system, it's also possible to place the amplifier modules in one housing, and then everything does not need to be touched and is pre-aligned.
Very good. Very good, and very nice also the kind of applications. Thank you for sharing all the information with us.
Thank you for giving me the opportunity.
I think there is no more questions, so we are a little bit out of time. So I would like to thank again all the speakers for presenting their new products today. So thank you also to the attendees for being here. If you are interested in discussing more in detail with any of them, feel free to contact them directly, also to contact me, so I can introduce you to them and you can discuss your doubts or make your comments by email. And thank you again, and I hope to see you soon in our next